All right. So first, I want to talk about factoring. It's again me, Mr. Witzak. I'm coming at you from my office in my bedroom. So we're going to talk about factoring when a equals one. So we have quadratics where we have ax squared plus bx plus c, and we actually have to factor x squared plus 5x plus 6 into two binomials. So what we do here is we look for factors of 6 that sum together to make 5. So the first method that I'm going to use is one that you guys don't typically use as much, um, but it's making a list. So I'm going to write down here the factors of 6, and then we want them to sum to 5. So as I list those factors, we have 1 and 6. Well, when I add those, that's 7, so that's not it. And then also factors of 6 could be 3 and 2, and then that makes 5. So then we put the 3 and the 2 at the end of the binomial. So we have x and x, and then we put the 2 as positive, so we put plus 2, and then we put the plus 3 here. And again, we can verify that this binomial that's in factored form now is actually the same as this trinomial in standard form if we just go back and check by distributing. So x times x makes x squared. X times a positive 3, I have plus 3x. And then plus 2 times x, plus 2x. And then plus 3 times 2 is plus 6. Or we have x squared plus 5x plus 6. So that method actually most of you don't use. You guys more similarly use the method where we make an area diagram. So I'm going to use that method here to display how I would move this trinomial in standard form to factored form. So what I do first is make my area model. And in my area model, I know that the x squared term is in the upper right. And then the constant term, the negative 24, is in the lower left. So that means I'm going to have my x and my x there because x times x is the only way to make x squared. So I need factors of negative 24 that add together to make negative 5. So what I'm going to do is just make that same kind of list over here. So I'm just going to write F for factors. And I have 1 and 24, or factors of 24, are 2 and 12, 3 and 8, 4 and 6. Now I also know that one of them is going to have to be negative because a positive times a negative is negative. Now I'm going to smartly also know that when I add those numbers together, in order to get negative 5, the negative factor has to be bigger. So right here on my list here, I'm going to make all the second numbers negative. So I'm going to write negative, 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 negative. And then I'm going to add them. So 1 plus negative 24, negative 23, so no. 2 plus negative 12, negative 10, so no. 3 plus negative 8, that's negative 5. So this is a factor that I want. So I'm going to put the 3 here, and then the negative 8 here. And then I'm going to put that right like this. So that's going to be my x plus 3. My negative 8 is there. So if I pull that out, and that obviously looks sloppy there, but it helped you guys when I write the plus 3 in my students in my regular algebra class to put the parentheses around that. So you can see now in factored form, we have x plus 3 and then times x minus 8. Now to go back and verify that, we actually need to fill in those parts. So right here, we would multiply 3 times x and get 3x. And then here, negative 8 times x is negative 8x. And then in combining my like terms on the bottom to just check, I would have x squared. And then 3x minus 8x would be minus 5x, and then minus 24. So either method will work, and then just check out the next videos to see what you might need, or if you need some extra.